So we left off talking about simplifying square roots, and we were breaking down numbers inside square roots, doing a prime factorization, looking for pairs, pulling out pairs, leaving singles inside. Okay. Now, some of the other types of problems that we may run into are square roots involving fractions. And depending on the situation, we have to treat each one of these a little bit differently. Okay. When you have the square root of a fraction, you can always split it up into like the square root of 25 over the square root of 9. Now, what's the square root of 25? And the square root of 9 is 3. So this would just be 5/3. Okay. If we do that with b, we'd have square root of 16 over the square root of 3. Can we take the square root of 16? Square root of 16 is 4. But we can't take the square root of 3. Okay. Now, this is important. In order to be considered simplified, you cannot leave a square root in the denominator. You cannot. So we have to do something called rationalizing the denominator. Okay. We have to do what is called rationalizing the denominator. So what we do is we are going to multiply the top and bottom of that fraction by something that will allow us to simplify the square root of 3 down to no longer having a square root. Now, we are going to work with relatively simple examples for now. And what we do to rationalize the denominator is multiply by that square root. So, in the numerator, I would have 4 times the square root of 3. In the denominator, what happens when I take the square root of 3 times the square root of 3? We would get the square root of 9, and the square root of 9 is 3. Whenever you multiply the same square root times itself, you just get the number. So the denominator would just simplify to 3. So that would be our answer for that one. So let's look at C. What would we do for C? Our first step would be square root of 5 over square root of 11. Now, can we simplify either one of those? So, I have square root of 5 over square root of 11. That is not simplified because I cannot leave square root of 11 in the denominator. So what do? I have to rationalize that, so I will multiply by top and bottom by square root of 11. So on the top, multiply your numbers together. 5 times 11 is So we end up with the square root of 55 over 11. And we cannot take the 55 divided by the 11. The 55 is inside a square root. The 11 is not. Leave it as the square root of 55 over 11. When you are taking the square root of a fraction, the first thing to look for is, can you simplify the fraction? In other words, is 36 divisible by 3, or do 36 and 3 have common factors? Is 36 divisible by 3? Yep. So what is 36 divided by 3? 12. So square root of 36 divided by 3 is just the square root of 12. Now, is that simplified? How do we know when it's simplified? We break it down and see if there's any pairs. So what two numbers multiply to 12? 6 and 2? And 6 is 3 times 2. So I have a pair of 2's and a 3 left over. So this can be written as we take the 2 out front since it's a pair. We leave the 3 inside since it's a single. So the square root of 36 divided by 3 can be written as 2 times the square root of 3. So 200 divided by 45. If you type 200 divided by 45 into a calculator, you will not get a nice number. Okay, it's not a perfect, 45 is not a factor of 200. So we can't just divide by 45 and get a decent number. Okay, so let's just reduce that fraction if we can. So 200 is divisible by 5. 45 is also divisible by 5, right? So divided by 5, we get 9. Divided by 5, we get 40. So now I have the square root of 40 divided by 9, which I can split into the square root of 40 divided by the square root of 9. Now, the square root of 40, if you typed square root of 40 into a calculator, you would not get a nice number. It is not a perfect square. So we'll have to break that down. But what about 9? That's 3, right? So 9 breaks down to 3. 40 is what? 10 times 4, which is 5 times 2, and 2 times 2. So we have a pair of 2's. Left over 5, left over 2. So we'd have 2 times the square root of 2 times 5 is 10, all over 3. So try to reduce the fraction. See if there's any perfect squares. Break it down. What happens if we add in variables? Okay. Adding in variables really doesn't change anything as far as what our end goal is. We are still looking for pairs. So if we have variables inside a square root and there's 2 of them, we can pull out that pair. If there's an odd number, some of them are going to have to stay inside and some can come out. But always start when we're dealing with a fraction by simplifying that fraction. So I have 12 over 3. Can that reduce? 12 over 3 is 4. So I'd get 4. And then x to the third divided by x. So we have 3 on top, we have 1 on the bottom. What we're going to do is subtract. So 3 subtract 1 is, so I have the square root of 4x squared. What is the square root of 4? And how many pairs are in 2 x's? 1 pair, right? 1 pair in 2. So we're just going to take out 1x. There may be occasionally a time where we have a quadratic equation where both sides are perfect squares. Or just like we looked at with like way back on Monday, where we could take the square root of each side and solve. Okay. Now, sometimes it's obvious that we just have an x squared, and so we know to just solve it that way. Other times it's a little less obvious. Now, the likelihood that we are actually going to end up with a quadratic equation with a nice perfect trinomial, perfect square trinomial on the left and a perfect square on the right is rare. But we'll still look at this because this will help us build into what we are going to do next week in what we call completing the square, which will mean that we're actually trying to create a perfect square trinomial out of what we're given so that we can then take the square root and solve. So if you look at x squared minus 14x plus 49, our really only method right now for solving a quadratic equation like this is to try to factor it. So we are going to try to factor this. So I need what? 2 numbers that multiply 2. So multiply to 49, add to negative. What numbers multiply to 49? Either 1 and 49 or 7 and 7. So 7 and 7 have to be our winners, right? And it has to add to negative 14, so these are both going to be negative. So what we get, we can write this as x minus 7 squared equals 25. And to undo a squared, we take the square root, right? So I get x minus 7 equals, remember we're doing positive or negative, 5. Which basically leaves me with 2 equations. I have x minus 7 equals positive 5 and x minus 7 equals negative 5. Just solve each of those. So add 7, add 7, add 7, add 7. So x equals 12 and x equals 2. If we factor x squared plus 4x plus 4, 2 numbers that multiply to 4 that also add to 4 are 2 and 2. So X plus 2 squared equals 16. Take the square root of each side. So x plus 2 equals positive or negative 4. So we have x plus 2 equals positive 4, or x plus 2 equals negative 4. Subtract 2. We get x equals 2 and x equals negative 6.